Great to see you here again. My name is Luc de Ceuster, founder of the Ceuster Academy, and I welcome you to a new video on our YouTube channel. If you didn't subscribe yet or you're here for the first time, click on the subscribe button, click on the bell button, so every time we have a new video, YouTube will inform you. In this new video, I will talk about conversions between numbers. And in this special case, I'm going to look at the conversion between binary numbers and octal numbers. Binary numbers having base 2 and octal numbers having base 8. But let's have a look what this means. Here we have a number, a decimal number, base 10, so it means it's a decimal number. We can say it can be written as a combination of binary numbers where every power of 2 has a coefficient a index I2. And for the binary numbers, the index a, or the coefficient a index 2, is between 0 and smaller than 2. Basically, this means that the coefficients of the binary numbers are in fact either 0 or 1. We have the same for the octal numbers, but here we have a base 8, so the coefficients a index 8 are the coefficients of the powers of 8, and they are between 0 included and 8 not included. Basically, it means that the coefficients are between 0 and 7. But let's have a look at the number. Let's look at the binary number and see how we can transform this in an octal number. So we have a binary number 110 and 101. Now, in order to do this, let's first have a look at the difference between the decimal numbers, the binary numbers, and the octal numbers. Now, when we look at the decimal number 0, binary this is 0, 0, 0. In octal this is 0. The number 1 is 0, 0, 1, 1. 2 is 0, 1, 0 in octal 2, and we continue for the number 7. In binary we have 1, 1, 1, and in octal still 7 because we can go up to 7. But when we go to 8, we find 1, 0, 0, 0, and that's larger than 7. So basically what we see is that the octal numbers are in fact given by sets of 3 binary numbers. And that's what we are going to do here. We're going to split this binary number in sets of 3 binary numbers. The first set we have here, it's a very simple number. This is the indication of 8 to the power 0. Here we have the indication of 8 to the power 1. And now we have to calculate what's the coefficient of 8 to the power 0. Well, this coefficient is 4, 0, 1. So this coefficient here is equal to 5. For 8 to the power 1, we do the same thing. We add the numbers here. So we have 4 plus 2, which is 6. And it means that this number, this binary number 110101, is equivalent to the octal number 65. And we put the index 8 to be sure that everybody knows that 65 is an octal number. It could be a decimal number, it could be a hexadecimal number, but it cannot be a binary number. So the index is there to be sure that we're using the right base when we're describing the numbers. Let's have a look at another binary number. We apply the same principle. The first thing to do is to split this number in groups of 3 binary numbers. So we have here the first group, the second group, and the third group. Now we are going to put there what are the powers of 8. And we start from the right, from the lowest number. So this is 8 to the power 0. This is 8 to the power 1, 8 to the power 2, 8 to the power 3. And now we calculate the coefficients for these powers. So this is 4 plus 2 is 6. Here we have 7, that's an easy one. This is also an easy one, it's 1. And this is 4. So basically what we can say is that this number 1 0 1 1 0 1 1 1 0 0 1 1 0 0 in binary base is equal to the octal number 6714, index 8, to be sure that we all know that this number is in octal. The thing that we have to do now is to describe the conversion from octal to binary. When we have this number, we can write this as 6 times 8 to the power 3 plus 7 times 8 to the power 2 plus 1 times 8 to the power 0 plus, sorry, this is power 1 and 8 to the power 0. So basically when we look at this number, we can say this is 6 times 8 to the power 3. This is 7 times 8 to the square. This is 1 times 8 to the power 1. And the last number is 4 times 8 to the power 0. Now what we know here is that 6, we look at the coefficients and we write them in binary, is 1 1 0. 7 is always an easy one, 1 1 1. 1 is also an easy, 0 0 1, and here we have 1 0 0. So basically what we can say at the end of this exercise is that the octal number 6114 is equal to the binary number 110111001 100, and we don't forget the indication that this is base 2, that this is indeed a binary number. Let's do another exercise. To finish this video, let's do this last exercise. We have the octal number, 72,650, and now we are going to write this as the sum of those different coefficients of those powers of 8. So we have here 7 times 8 to the power 0, 1, 2, 3, 4. Then we have 2 times plus 2 times 8 to the third plus 6 times 8 to the second plus 5 times 8 to the power 1, and the last one plus 0 times 8 to the power 0. And like we did in the previous exercises, we're going to write those coefficients now in binary format. 7 is 1 1 1, 2 is 0 1 0, 6 is 1 1 0, 5 is 1 0 1, and the last one is 0 0 1. And we put 2 there. So basically what we can say is that those numbers are in fact equal, although 72,650 is the octal number and the binary equivalent number is 111, 010, 110, 101, 002. Of course, it takes 2. That's what I wanted to teach you in this video about the conversions between binary and octal numbers. Anyway, don't forget to look below the video in the description. You will find a lot of links to different courses and coupons for great discounts. Anyway, you know what happens at the end of the video. If you didn't subscribe yet, this is the moment to do it. Click the subscribe button, click on the bell button, and YouTube will inform you every time we have a new video. I thank you very much. I hope you enjoyed this